Let's go ahead and refresh ourselves on multiplying, dividing, adding, and subtracting fractions. Here are some examples. The first one is 1/6 times 4/5. So when I am trying to remember how to multiply fractions, all I remember is multiply numerators and multiply denominators. However, before I do that step, I usually like to simplify first. And what I notice is that 4 and 6, any numerator and any denominator, if you find a common factor that it can be divided by, then you can simplify. So both of these numbers are divisible by 2. And so I'm going to divide both of them by 2 and leave the factor that's remaining. Now that I have simplified it, I can multiply numerators. 1 times 2 is 2, and 3 times 5 is 15. So I know that my answer is in simplest form. Let's look at the division problem. What I remember for division is keep, change, flip. So I keep the first fraction and I get 5/3. I change division to multiplication and then I flip the second fraction and I get 2/15. Now that it's a multiplication problem, I'm going to try to simplify first. I notice that both a numerator and a denominator are divisible by 5, so I'm going to divide by 5 and write down the factors that remain. Now I have multiply numerators. 1 times 2 is equal to 2, and multiply denominators. 3 times 3 is equal to 9. 2/9 is the answer to the division problem. Now that we are subtracting and adding fractions, in order for us to do that, we have to have common denominators. In this case, I can keep on doubling my 7 and pretty much I would need to multiply the 7 3 times in order to get my common denominator. So I'm going to choose 21. And what did it take for 3 to become 21? You needed to multiply by 7. And so whatever I do to the denominator, I need to do to the numerator. So that gives me 1 times 7 is 7. In this case, what did it take for 7 to become 21? I needed to multiply by 3. So whatever I do to the denominator, I also need to do to the numerator. So 4 times 3 is 12. Now that I have the same denominators, all I have to do is subtract the numerators. 7 minus 12 is equal to negative 5, and then I keep the denominator the same. So if I've worked so hard to have common denominators, then I need to make sure I keep the denominator the same. Let's look at the addition problem. Again, I need to find common denominators. But before I even begin working, I already know that I can simplify 4/2, and so I'm going to go ahead and do that and make that be 2/1. That's going to make it easier for me to do all of my multiplication in my head to find a common denominator. My common denominator between 5 and 1 is 5. That means that 3/5 gets to stay 3/5, and all I have to do is change this to a denominator of 5. What did it take for 1 to become 5? Times 5. That means that I have to take the numerator and multiply that by 5, and I get 10. Now that I have uh, 10/5 as my fraction, I can add the numerators and keep the denominator the same. That gives me 13/5. So 13/5 is the answer to that fraction addition problem.